Hello, the purpose of this video is to show the thermal issues that I'm having with my 2015 MacBook Pro. I have a 15-inch model with 16 gigabytes of RAM and a Radeon discrete graphics card. Now lately what's happening is if I hook my MacBook Pro up to an external monitor and launch the Chrome browser, I notice the fan speeds go on to full blast, and that's indicating that the temperatures are getting really hot inside the MacBook. Now I've never really documented it or installed any applications to check or verify it until now. And so the purpose of this video is actually, one, to show you the thermal issues that I'm having, and maybe you're having similar ones, and also set a baseline test because I'm going to install Thermal Grizzly liquid metal in this MacBook and see if that can improve the thermal issues that I'm having with the system. Now I have an application running right now that's called Temperature Gauge Pro, and I bought it so that I could control the fan speeds and also monitor the core temps of the processor on my MacBook, and I can also monitor the GPU temps, which is kind of cool. And then I also installed a free software from Intel that lets you actually look at the core frequency to see if we're actually reaching T-junction and to see if we're thermal throttling, and the computer's actually going to lower the clock speed so that it can handle the thermal issues that are going on inside the computer. So I also have a clock just to see how long it takes to reach T-junction, if we even reach it, and to see how long it takes for this computer to heat up. So the first thing I'm going to do is just close the About page. Make sure that I have no other applications running. I'm going to go to Force Quit. You can see that I've got the stopwatch, QuickTime, and Intel running. So what we're going to do is go to System, go back to Stock System Fan Speeds, and we're going to hit Start. So the fan speeds should drop basically down to 0, and you can see just recording the screen right now that the temperatures are going to rise. We're already going up, so we're at 70 degrees Celsius. We were kind of below that. Internally in the computer, it's 49 degrees Celsius, and the CPU average is about 69, 70 degrees Celsius. We are running at the right recommended frequency for the CPU at about 2.53 gigahertz. Now, let's simulate the problem. I'm going to go down and click on the Chrome browser. I'm going to launch that Chrome browser. Bring it over. You can see the temperatures rose dramatically. They're already up into the 90 degrees Celsius range. Fans are going to start turning on. I'm going to go to 4K video, just play a video, hit play, and then I'm going to go ahead and expand that. Then I'm going to move this over to the other screen. You can already see I'm in the high 90s already on the computer, and the fans are going to have to turn up. We'll give it a second and just see how long this takes. We're already at a minute, and I'm already in the 90 degrees Celsius range. Over here it says I'm 95 for the package for my CPU. That is extremely hot, 97 degrees Celsius. If it goes any higher, it's going to have to take the CPU speed and lower it so that it can control everything on the computer. Now, I'm going to bring this back and just let it keep playing so you can see what's happening. So this is what I kind of noticed when I played a video on my computer. And it was kind of concerning me because the fan shouldn't be on full blast for the video, and I shouldn't be having these high of temperatures. So let's see if it turns the fans on the highest setting as it can. Here it goes. It's going up. It's reached pretty much maximum speeds on the fans. I'm in the 90 degrees Celsius range still. Now I haven't reached T-junction, so I'm not thermal throttling yet. So let's move this off the screen. Now if I actually load another application, let's just open Word. Maybe Word will do something to it. I don't know. This is an experiment. All right, so I opened up Microsoft Word. I'm double clicking on a document to start a new document. Notice that the computer is now starting to hang up a little here. And you can see a huge dip right here. So it showed that just opening Word, the processor speed downclocked in order to control the temperatures. All right, now let's close Word. And let's open up iMovie. Maybe that's a little more taxing on the CPU. You can see that we're definitely thermal throttling now. Computer is starting to perform slower. My application is hanging up. Let me bring it down. You can see that we are now thermal throttling because I opened iMovie. We're going all the way down almost to 1 gigahertz on my core speed. and my fans are on full blast, and I'm sitting at 80 degrees Celsius, and my video is actually struggling. So if I bring it over here, it'll hang up a little bit, like you can see it hanging up right now. And let's take a look at the GPU temp. GPU temp is in the 70 degrees Celsius range now. Inside my computer, it's 55 degrees Celsius. CPU is 75 degrees Celsius as a package. And the reason why the CPU is at that temperature right now is because it's thermal throttling itself and basically lowering the temperature by not letting the CPU run at the recommended frequency rating. So we're only 3.5 minutes into this video, and you can see why I'm concerned. So my goal is a couple. One, to document the thermal issues and to actually see if I was reaching T-junction, which we were, and to see if it was thermal throttling my processor. And then I want to see what happens when I put liquid metal inside the computer and I put it on the CPU and GPU inside, and then run these same tests again and see if I reach T-junction, number one, to see if the fan speeds have to go to full blast in order to control the temperatures on my computer, and to see if I actually have better performance by upgrading to a better thermal compound. Thank you so much for watching this part of the video. The first item you're going to need is Scotch Super 33 Plus electrical tape. Now it has a thermal rating of 105 C or 220 degrees Fahrenheit. The second item you're going to need is the silicone modified conformal coating from MG Chemicals. This will actually liquid proof the components on the processor board, so the circuits won't short out if any liquid metal were to go on to the processor board. And then of course the last item you're going to need is the Conducta-Not Thermal Grizzly liquid metal. Now when we open up the package and dump out the materials, you're going to see where the liquid metal is right here. And then you're going to unscrew the cap, and then you're going to apply this applicator tip, not the other one. And then it will squirt out, so you have to squirt out on another surface and then plunge it back in, and then you can take a very small amount and put that on top of the processor and GPU on your MacBook Pro. The Q-tips are great for moving around the liquid metal. You want to get a nice coating that's very thin. You don't want it to be watery. Do not use this tip. Alright, so I'm going to remove the 10 P5 screws. You're going to need a P5 pentalobe driver bit. You're going to want to make sure you keep the screws in the order and location that you removed them. Now, right now I'm just putting them on a piece of paper to go quickly. I recommend either using the iFixit mat, which is magnetic, or drawing it on a sheet of paper and taping it down so you can put the screws exactly where you took them out. Now, I've already made this mistake, so the screws are not all in the right locations anymore. But I'm going to work around the MacBook and remove the screws. Now, before I get all the screws out, there are two clips in the middle of the back plate. So when you pull up, you kind of want to work your hands around the panel so you can loosen up the clips. Don't tug too hard from just the middle. It'll cause them to break. So I'm going to take my hands and kind of work around the edge until I feel the clips loosen up, and then I'm going to open up the MacBook Pro. You'll see the two clips right here on the back plate, and they clip in right here on the center of your MacBook Pro. Now, it's highly important you remove the battery connector immediately. You can use your fingers to pull back the tape and use the blue pry tool from iFixit, or your fingers, and disconnect the battery connector. Next, you're going to take a T5 Torx bit and you're going to remove the screws that are holding the heatsink on your MacBook Pro. Now I'm removing the top left screw. Because I have it turned around, it's going to be different. It would be in the bottom right corner if you had yours turned around. I'm going to remove the two flaps, and then now I'm going to remove only two of the CPU block screws. Alright, now they're spring loaded, so be careful, have some pressure so you can catch the screw as it's rising. I'm going to remove the last screw at this time, and again, hold pressure. Alright, and then you're going to want to swing those arms out of the way so that when you remove it, it won't catch them. Now I have 4 screws for the GPU block because this has a discrete graphics card on it. If yours does not have a discrete graphics card, I don't believe you'll have these 4 screws. But I'm going to go ahead and remove them at this time. And I have 2 remaining screws left. Now there's not a lot of pressure on these screws, so you can be a little bit less careful when you're unscrewing them. Now the last screw that I need to remove is actually hidden under a cap beneath the left fan or in the top right fan if it was turned the other way. And I'm going to remove that cap and then unscrew the last and final screw. Now the heatsink should remove fairly easy. All you're going to have to do is lightly pull on both corners of the heatsink and raise it off the MacBook Pro, like so. Next, you're going to take your Q-tip and 90% isopropyl alcohol, and you're going to scrub and clean off all the thermal compound on the CPU and GPU. Now, I've already done this process on the CPU and removed the tape that came from the factory. I'm now going to take the conformal coating and I'm going to apply several layers to the CPU board to ensure that no shorts occur if the liquid metal were to touch the board. Now I kind of went overboard and did several layers. It's up to you. I'm also going to make sure I clean off the CPU and get it completely ready. Now I'm going to remove the tape off the GPU die so that I can clean off the remaining thermal compound that is on the chip. And I'm going to make sure both the CPU and GPU are clean now. Now I'm going to add the conformal coating and add several layers to the GPU chip so that no liquid metal will cause a short if it touches any of the connectors. Now I made several mistakes in this video. One is I applied the liquid metal before I put the electric tape on the CPU and GPU chip, and I even used the wrong type of electrical tape. I didn't use the Scotch Super 33 Plus tape, so I'm actually going to have to take it all apart again and reapply the correct electrical tape. You're going to want to take the liquid metal and apply a very teeny dot on your CPU and GPU die and take the Q-tip that came with the liquid metal thermal Grizzly package and spread it evenly across the surface of the CPU and GPU chipset. Now keep in mind, if you see puddles or have any excess come off, just immediately clean them up and make sure you don't have too much on the chips themselves. Next, you're going to want to take the heatsink and you're going to want to clean off the copper plate for both the CPU and the GPU. You're going to take 90% isopropyl alcohol and a Q-tip, and you're going to want to scrub off the surface of the copper plate. Now you can see that the thermal compound that was on the MacBook Pro is very dry. I think this is the main reason why I was having high temperatures, because it wasn't doing an adequate job of transferring the heat off the CPU and GPU to the copper plate and out the fins on the heatsink. I'm going to go ahead now and clean off the GPU copper plate with a Q-tip, and you can even see here that it is not even sticking at all to the Q-tip. It's just sliding right off the surface of the copper plate. So that's probably the main reason why my Mac was overheating. Now what you're going to want to do is take liquid metal in a second and apply a thin layer to both the CPU copper plate and the GPU copper plate. You're going to want to put it exactly where it connects to the surface of the CPU and the GPU. Be careful not to add too much. You just want to add a nice layer so that they connect when you put it back together. So I made several mistakes in the video. One, I should have taken the electrical tape first and put it on the CPU and GPU board and taken a pry tool and pushed on the corners and the tape to make it really flush or stick to the actual CPU board and GPU board, so it makes a real good barrier. My biggest mistake was I used electrical tape that's only rated for 80 degrees Celsius or 176 degrees Fahrenheit, and the CPU and GPU can get up to 100 degrees Celsius. So I had to do another video, and I'm actually going to take everything apart again and show you what the liquid metal looks like afterwards and see if I had enough, and also see what happened to the tape, because I was quite concerned about what the tape did. Now after you get all your tape on the CPU and GPU, you're going to take the heatsink back on it and make sure that you get it lined up perfectly straight, and then push down on it and then apply the screws to connect everything back together. So I took the MacBook Pro apart after a few days, and I'm now applying the correct electrical tape to the CPU and GPU board. Now something I noticed that is very concerning is that the CPU doesn't look like it has enough liquid metal, and it has a bare spot. So I'm going to apply some more liquid metal to it and spread around the CPU and GPU chip the correct amount of liquid metal. Now I will soak up any excess liquid metal with another Q-tip if there's a lot of puddles on the surface of the CPU and GPU. Now a little tip, use calipers and measure the exact length and width of electrical tape you need, so it makes it easier when you're cutting it. And then you're going to want to take that blue pry tool and you're going to want to push up against the electrical tape onto the board and the CPU edge, so you make a real good barrier so liquid metal can't move around on the CPU and GPU. Okay, I've installed the liquid metal on my MacBook Pro and I can already tell a difference in the thermal performance and the temperatures on the CPU cores. Now, I'm currently recording with QuickTime and I'm putting a slight load on the processor, and you can see it's sitting in the 60 degrees Celsius range and the fans are not even on. So let's take a look what happens when I load Chrome like I did in the previous test without liquid metal. I've launched Chrome and you can see that it did not shoot up into the 90 degrees Celsius range and the fans come on. That did not happen. Now when I typed in 4K video and I played a 4K video in the background, that's when the processor in the previous test really shot up on the temperature on the CPU cores. You can see the temperature rose a little bit. The fans are not even turning on yet, and there's no thermal throttling occurring on the CPU. It's handling everything fine because the temperatures are under control. Now, if I click on iFixit video, that's where thermal throttling immediately occurred, and basically iMovie froze. It's not frozen, and there's no thermal throttling happening. The fans are coming on a little bit, and you can see the temps are slowly coming up. So the liquid metal is doing a great job of transferring that heat off the CPU GPU die to the copper plate and out the heat sink with the fans blowing it out the MacBook. Now I'm already seeing a huge improvement. So there's no slowdown. My tasks are running just fine. I can multitask. I'm going to load Word, throw another application open, and I'm going to launch a blank document. And I'm going to bring it down, and you can see temperatures went up a little. Fans are still doing just fine. They're going to come up a little bit because I got more than one application running. I'm going to load PowerPoint now at the same time. You can see it put a strain on the CPU for a second there. Bring that down, and you can see the fan speeds are coming up a little bit more. Temperatures are still being regulated. Not seeing any real major thermal throttling occurring. It's still able to run at its high frequency rating that it's spec'd at. I'm going to load Excel at the same time. Load a blank document. I'm going to bring it down, and you can see the liquid metal is doing an excellent job of managing the thermal transfer of heat and dissipating it out the back of the MacBook Pro. So if you have a MacBook Pro, just changing the thermal compound will help you out significantly. Liquid metal is probably the best performance you're going to get, but it does come with some costs. You're going to have to put non-conformal coating on the CPU and GPU chip. You're also going to have to use electrical tape to add another barrier, and you're going to have to be very careful with liquid metal so that you don't cause any shorts to happen because it is conductive material. But look at that. I mean, I have all these programs running. I can scrub across the timeline. I have no thermal throttling happening. Everything is functioning the way it's supposed to, and it's a high-performing MacBook now. So that's awesome. But now what I'm going to do is what I wish I did before. All these applications, and I'm actually going to cause all 4 cores to be stress test by opening the terminal and putting in a command to stress test the CPU cores. Now let's see what happens with the MacBook Pro when I do this, and I test how well it can manage that workload and dissipate the heat. So let me open terminal, and I'm going to paste in my command, and I'm going to put all 4 cores on a full load. Now I'm actually going to go ahead and open right here the activity monitor. You should see yes, 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 and yes. That shows you 99% load on each core on the CPU. And then over here, you can see that we're not thermal throttling. Each CPU is being tasked to its max capacity. You can see the fans are on full blast, and you can see right here on the processor temps, they're getting toasty, but they're not out of control. You're not seeing the processor have to thermal throttle and lower the frequency to manage the heat now. So that's just showing you that you're getting a significant improvement now with liquid metal being on the CPU. Now, to do something that's really going to push it over the edge, I'm going to launch Heaven Benchmark. And that Heaven Benchmark actually tests the GPU. Now, I don't have it on windowed. I'm going to hit run. Now, this is under the CPU that's already under max load. So it should cause some issues with the CPU. But now it's running that GPU benchmark. And in a second, it should be up and running. So there's the GPU benchmark running. All 4 cores are still being tasked. Now you see a dip here, and that's because the processor is having to do the 4 cores at full load and run Heaven Benchmark at the same time. But take a look. The GPU temp is totally reasonable now. It's at 79, 80 degrees Celsius with, and you saw the heat sink, it's right next to the CPU, and I'm sure the CPU heat would go also to the GPU heat and put some heat on the GPU, but it's fine. CPU temps are under control. GPU temps are under control. Now there's a slight thermal throttling occurring because the CPU can only handle so much, but it's doing a great job of not thermal throttling to the point of going down to 1 gigahertz. Now if I close the GPU benchmark, you'll see that the thermal throttle or the CPU strain, and it'll shoot back up, and all 4 cores are still being tasked as we speak. So this is awesome. So my MacBook is now running at full speed and top performance because of this simple change in the thermal compound on the CPU and GPU. I'm going to end these tasks, and the CPU cores are no longer going to be running at their full capacity. You can see I killed that process, and then you can see the temps immediately drop on the GPU when I killed the other program. And look at the CPU, it's coming down very quickly in temperature. So highly recommend it. Changing the thermal compound and going to liquid metal has really improved the MacBook performance for me. Thank you so much for watching this, and I hope this tutorial was helpful for you and it benefits you if you try to do this in the future. So I thought I'd put together a chart just to document everything that I saw. And as you can see in the chart, that if I had launched QuickTime with the Apple stock thermal paste, there's no fan speed, but the temps went up to 78 degrees Celsius. With the liquid metal paste, the temps only went up to 65 degrees Celsius with no fans running. But then what really separated the two is when I opened Chrome and launched a video. With the Apple stock thermal paste, I had 100% fan speed, and my temperature went up to 95 degrees Celsius. With liquid metal, it stayed at 70 degrees Celsius, really close to where it was with QuickTime, and I had 0 fan speed. So that's a huge difference right there, and alone the fans aren't having to turn on, and the thermal temps are not really increasing. Then if I launched QuickTime, Chrome Video, and iMovie, that's when the Apple thermal paste basically just stopped. That's where thermal throttling happened. I went all the way down to 1 gigahertz with 100% fan speed. Incredibly, with liquid metal, the fans only went up to 10%. I have no thermal throttling occurring, and the MacBook is functioning at a range of 80 degrees Celsius. So there's not a huge jump in temperatures with liquid metal when I start adding on more tasks and more applications. And then with liquid metal, I continued on because there was no thermal throttling, and I launched Word, PowerPoint, Excel while the 4K video is running, while iMovie is running, and while QuickTime is doing a screen record, and the fan stayed at 10%, and actually my temp started to come back down to 72 degrees Celsius, I think because the liquid metal was doing a great job of transferring the heat to the copper plate and out the fins on the heatsink. Then I decided to CPU stress test and see if I could get thermal throttling to happen with all 4 cores at max usage, and you saw that with 100% fan speed, there's no thermal throttling happening. And so then I decided to do a GPU stress test at the same time, and still the fans were at 100%. There was some thermal throttling, and that's why the temps came down from 99 degrees Celsius down to 90 degrees Celsius. So liquid metal is clearly doing something, and it is helping out with my MacBook and allowing the performance to stay at a high rate and allow multitasking to occur, and at the same time have my fan speeds go down dramatically.